Hello students, today I again repeat that point number system and codes. Number system define set of value use the represent the quantity, and the number of values that digit can always equal to base of the system. It is also called as radix of the system. For example, decimal number of the system base is 10. Every digit can assume 10 values 0 to 9. The largest value of the digit always 1 less than base. For example, largest digit of the digital system decimal number system is a 9 and 1 less than base number. So, each digit position represent different multiple of the base that have no positional importance. So we can implement common rule for all numbering system as follow. For general number, we can have multiple each digit by some power of base or radix. The column number is assigned to number of the digits, and the relation of the decimal point, that is the column number of the left of the decimal number starts with 0 1 2 3, and as shown in a diagram, and to the right of the decimal number start -1 -2 -3 as shown in that diagram, column number diagram. And there are the various number system and their bases. The various number systems: binary number system base is 2, octal number system base is 2, decimal number system base is 10, hexadecimal number base is 16. There are the different these are the different number system that in last point in the last point the digital system process the digital signal. So this system is known as a digital system, and the digital signal is having the distinct value, finite number of value. So that signal is known as a digital signal, and if that distinct values are 0 and 1, then 0 and 1, then that signal is known as a binary signal. If that distinct value for that signal having 0 to 7, then that signal is known as a octal signal. If the distinct values are from 0 to 15, then that signal is known as a hexadecimal signal, and that all signals are processed by the system is known as the different number systems, that is a binary number system, octal number system, decimal number system, hexadecimal number system. And in this second diagram, there is a column number is assigned for the digit relation with the system. And in this column number system, there is the one radix point, and in this radix point, this is the main radix point or base point. From that left hand side of the number system, column number system is assigned, and right side of that decimal number or any system we assign with the powers of minus. This x is a represent in this column number as a number, and b is a represented as a this is a base of the system, and left hand side of the base system in terms of power positive, and in terms of right hand side represent the negative terms. Binary number system. First, the binary number system has a base 2, so it has only two digits, namely 0 and 1. The weights of the binary number are given by as that positional value of column number represent as a weighted position: 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4 into a dot, that is a base point or radix point, and right hand side represent the 2 raised to -1, 2 raised to -2. And in this binary number system, that is a decimal to binary first conversion. In this decimal to binary conversion can be converted into its equivalent binary form, successively dividing the number of two and noting the quotient and remainder, and the division of the quotient by continuously by 2 with until it is not a number longer divisible by 2. And equivalent number of binary is read from bottom to top, that is MSB to LSB. And in case of decimal fraction is if that decimal number is in the fraction, then that fraction number multiply by 2. If result has a 0 before the decimal, it is noted and the procedure is continuous depending upon the number of digit required. First, that in conversion, that is a first 25 convert into binary. So for 25 convert to binary, this is the decimal number system. For that decimal number system, base is 10. So this is the decimal number system, and this decimal number system is converted into binary. So for this decimal number system, we divide by 2 and we quotient the remainder and quotient and remainder. So this is a divided by 25 by 2. So that answer is here 2 and 1 is here remainder. Then again we 2 divide by 12. Then here remainder 0. Remainder is 0. Then 2 is divided by 3. So 1. Then 2 is not divided by 1. So answer 2 divided by 3, and here is a remainder, and 2 not divided by 1. So this answer is noted here, and we read that answer from bottom to top. So for 25 decimal number, there is a binary number is from bottom to top. That answer noted 11001. This is the decimal to binary. We convert that number if that number is in integer. If that number is second problem, if that number is a fraction, that is 0.875, this decimal number is converted into binary. This number is a fraction number. In that you have to multiply by 2. So 8075 multiplied by 2, that answer is 1.75. In this 1.75, 1 is here, and again 0.75 multiplied by 2. 1.75 into 2, answer is 1.5. In that 1.5, here answer is where remainder is noted. From this 1.5, 0.5 into 2, that 0.5 into 2 means answer is 1.0. So from this answer is 0, so we stop here multiplying. If answer is 0, stop, or take the 1 or 2 or 3 times multiplication, and if the numbers are repeated here, multiplication is repeated, then that multiplication is stopped. So this from this 1.0, answer here is a 1. So we note that this from top to bottom for the fraction number. So answer is 875. For decimal, convert in a binary 0.111 into binary. Decimal base is 10, and that convert into binary. First conversion we see, that conversion is a in a binary 0.11. If the fraction number, then multiply by 2. Integer number divide by 2. For answer we noted that is from bottom to top, and if that fraction number, then from top to bottom. This is the conversion decimal to binary number system, that you have to in last lecture I take that in that notes all the problems you have to solve. Next conversion, binary to decimal. binary to decimal. In that binary to decimal conversion can be converted into equivalent decimal number from the multiplying the bits by their binary weighted position. That binary weights means in that diagram column number we assign there is a one base point, and from left hand side and right hand side that terms are in terms of positive terms or negative. In terms of powers, positive or negative we represent. That is a weighted position we assign for the multiplying the bits by binary weights. So the bits to the left of the side are multiplied by powers 2 raised to 0, 2 raised to 1, 2 raised to 2 in terms of LSB to MSB. LSB to LSB you have to represent, and the bits to right of the decimal are multiplied by negative powers by 2, that is a 2 raised to minus 1, 2 raised to minus 2, 2 raised to minus 3, or different weighted position in terms of negative. That is the weighted position you have to assign for any binary number. And in terms of base for the binary number system is 2. So in terms of base you have to represent the different weighted position, and that column number you have to assign for that number. And that in that diagram x into b raised to 0, x into b raised to 1, x raised to b raised to, that x is represent the number and b is the base of the system. For the conversion binary to decimal, so that we have to b is assigned as a 2 raised to as a base as a 2. First example, that is a 1 1 0 1 1, base is 2. So that conversion binary to decimal, base is 10. So that number you have to write first 1 1 0 1 1. This is your that number weighted are, here is a not base point. So this is the LSB bit, that is the least significant bit, and this is the MSB bit. So you have to start that binary decimal number, that is a weighted position in terms of powers, multiplying by bits by their weights, and that is assign that number from LSB to MSB. So this is the weighted position. First is a 2 raised to 0. For this 1, this is a 2 raised to 1. For this 0, this is a 2 raised to 2 power. This 1 is a 2 raised to 3. For this 1, 2 raised to 4. 2 raised to 4. So this number is converted as a weighted position, as we have to write that first, or here we take this 1 into 2 raised to 4 plus 1 into 2 raised to 3 plus 0 into 2 raised to 2 plus 1 into 2 raised to 1 plus 1 into 2 raised to 0. This first one here, and weighted position for this number is a 2 raised to 0. Next, this is a 1. This is the 1, that is x into b raised to 1, that column number. This x into b raised to 1, this x is a 1 into 2 raised to 1. This is a 0, 0 into 2 raised to 2. This 1 into 2 raised to 3. This for this one, this is weighted position 2 raised to 3. That numbers are left hand side, so that numbers are weighted position are assigned as in terms of power positive. So for this one, that weighted position 1 into 2 raised to 4. This is a 2 raised to 4. So answer is calculating 27 by 10. This is the answer we calculate, and that is a conversion binary to decimal. Again take one problem, that second problem, that conversion binary to decimal. That binary to decimal 0.11011 base 2, and that convert into decimal. So in this conversion there is a terms are from the radix point represent as a base point, that is represented as a here left hand right hand side. So for that number, this is 0, this 1 1 0 1 1, these are terms are from the right hand side. So for these numbers we represent the weighted position in terms of power negative. So we convert binary to decimal. So this for this number their weights are assigned in terms of base for the binary number system is 2. So this is a 2 raised to minus 1. For this 2 raised to minus 2, for this 2 raised to minus 3, for this 2 raised to minus 4, for this 2 raised to minus 4. So conversion 0.0 for this x means 1, 2 raised to minus 1. This is a 1 into 2 raised to minus 2. This 0 into 2 raised to minus 3. This 1 into 2 raised to minus 4. This 1 2 raised to minus 5. So answer we have to calculate, that is answer 0.84375. By Kelsey you have to calculate that answer. This is the example. Next third example, that 0.10 sorry 011 1.001, that conversion base is 2 converted into decimal. So number here to first write 010.111.001. in this start from LSB to MSB. LSB point here is the base point or radix point. For this one, this assigns the weighted position as a left hand side represent the in terms of power base 2 in terms of power positive. So this is a 2 raised to 0. For this one 2 raised to 1. For this one 2 raised to 2. This one 2 raised to 3. For this one 2 raised to 4. For this one 2 raised to 5. Point these are the represent as a in terms of power negative. So 2 raised to minus 1, 2 raised to minus 2, 2 raised to minus 3. Right terms are represent the negative. So this 0 into 2 raised to 5 plus this 1 into 2 raised to 4. This 0 into 2 raised to 3 plus 1 into 2 raised to 2 plus 1 into 2 raised to 1 and plus 1 into 2 raised to 0. This is the from that side. And point this 0 into 2 raised to minus 1 plus 0 into 2 raised to minus 3 minus 2 plus this 1 into 2 raised to minus 3. This is a 1. So answer you have to calculate that 23.125. This is the conversion decimal to binary to decimal conversion, and in this converted by equivalent multiplying the bits by their binary weights. This conversion is known as a binary